Hi, my name is Matthew Conley, and I'm here today to introduce SystemRDL and PeakRDL, single source register definition for FPGA and software development. What is SystemRDL? SystemRDL is a standardized register description language originally developed at Cisco Systems in 2009 and later moved over to the Allegra initiative in 2010. It provides a single source of truth for control status registers, replacing manual spreadsheets and custom RTL definitions. And it's open source. What is SystemRDL again? It's a description language that can be used to define registers, bit fields, address maps, access permissions, reset default values, documentation, metadata, custom fields, enum encoding, and more. And you can see here's an example of some SystemRDL that I generated for the Hi512G. What is PeakRDL? PeakRDL was invented by this dude right here, Alex Mitka, and it's essentially a compiler that takes SystemRDL and generates the following outputs. It generates synthesizable system Verilog RTL register blocks with a variety of bus interfaces, APB3 and 4, AXI Lite, and Intel Avalon, and more. There's more development going on this every single day. It generates a C register abstraction layer. It can import and export IP exact XML. It generates documentation, builds UVM register model abstraction for verification. It can generate a Python interface module, and much, much more. When he was designing it, he basically came across, so I mentioned earlier, this gentleman, Alex Mitka, he worked at SpaceX for a couple of years, and now he works in the Bay Area, some other company, I forget. And he made this a couple of years back and kind of just threw it together as like a toy, and then he put it online. And
it turned into Git?
It kind of, well, it's in Git, and it took off. But when he did it, he originally came across the thing of like, oh, we need this tool. What should we do? Should we make our own? Yeah, let's make one that's different and kind of just covers our own cases. And then you have 15 competing standards. So instead, what he did is he used SystemRDL, which was a known thing that existed in 2009 and is free and open source and accessible, and just built his toolchain around that. Has this ever happened to you? You're asked to add a new feature to a device or create a brand new device. You toil and generate a register Verilog module for said device, meticulously planning and implemented. Now you have to generate or update the Microsoft Word doc to reflect new feature or entirely new device register maps. Any software which will interface to this register map, or hardware for that matter, and access its features now has to be manually updated based on the info in the Microsoft doc. And here's a ChatGPT generated image of what that looks like. 5+ engineers doing their individual part. I'm doing my part. But what if it could look like this? One engineer, one source, everything generated. You're asked to add a new feature or device, you update the SystemRDL, all levels are automatically updated or created. Wait, where have I heard this before? Isn't this just HITL? Yes, but here's the difference. HITL still requires multiple manual file writes. You have a custom schema, which we came up in-house, which I still to this day have never seen, but I am sure that it exists. It's a toolchain specific implementation. It requires engineers still maintain at least 3 different documents. Limited ecosystem support, or if you go Google for help on HITL, you're not going to find it. Custom generators are maintained internally, which is man hours. That's kind of a bummer. Internal toolchain, single org usage, knowledge silo risk. SystemRDL and PeakRDL, on the other hand, write once, permeate everywhere. It uses an industry standard description language, formal language semantics, not ad hoc JSON, which also means it works really well if you have like an autocomplete in VS Code. So it'll pick up what you're trying to do and be like, oh yeah, you're using this field, and it'll color code. There's color coding for Notepad++ and VS Code and stuff. Supported by multiple tooling systems, generates everything from one SystemRDL file, and super extensible. People are writing plugins for PeakRDL every day to do custom stuff that they want to do, or adding custom fields to their SystemRDL. Industry defined, used prolifically. It was downloaded 46,000 times in the last week. And easily extensible. This seems kind of complicated. It's not. Installing, you just do pip or Python or pip install PeakRDL and you're in. Yeah, but it still requires work, right? Yes, absolutely nothing in life is free. I used this on the Hi5 Plus overhaul and the Hi512G. The Hi5 Plus took 30 minutes to convert the Microsoft doc to a SystemRDL doc, and the Hi512G took me an hour and a half. And then I threw the UTC-4K. I threw AI at the UTC-4K Microsoft doc, and it generated the whole thing in 5 minutes. So you do it once, and if you're going to do it manually, make an intern do it. Change once, permeate everywhere. Okay, so show me. All right, over here, let's go. So here's my SystemRDL. So I generated this for the Hi512G. It's got all the usual suspects. You've got your name, your description for the address map. You define individual registers. These are all common fields: name, description. Software can read or write. That's you're setting your accessibilities. You set your default values, much the same as you would set registers up in HDL. You set your bit fields for that particular field, so you can specify sub-bit fields, registers, bit fields, etc. This goes on. This is the one I did by manually. You can create custom enums for each one. You can use a standardized enum, but that would require all of your bit fields to share the same enum structures for whatever they do, which isn't always the case. So in my experience, it was better to just create custom enums for each field, but it really doesn't matter. You can, if you have one where it's kind of a universal enum, you can dictate a universal enum and use it throughout your program. And then if you are using the enum, you just specify that it's encoded here with the enum. You can even set the enum as the reset value. So cool. Really fun document to generate. It's a little bit tedious, but it is what it is. And like I said, AI can do it. You get really desperate.
Matt?
Yes, sir.
Could you slow down and give us an example of just like one register that has a few different fields?
Yeah.
How the entire definition looks like.
Yeah.
Can you also show the Word document side by side with your SystemRDL that you've written?
I can, but I can do one better. But yes, I can. Okay, so a register. So this is very hierarchical, right? So you've got your top. I mean, this is. Just do this one. So you've got the address map. This is the. You consider this your Microsoft doc, right? This would be the title of your Microsoft doc and the subtitle. And then here's the standard definitions of like default accessibility, default register widths, etc. Then you specify one register, which starts with these curly. It's defined by these curly braces. Name and description field. These are defined individual bit fields inside the register. And then here at the end of the register definition, where you put the address of the register and
okay, so this contains one field. It's 8 bits, and it's called module ID.
Right. Correct.
Software can read it, and hardware can.
Right. Correct. Yes.
Okay.
And if you have one with sub bit fields like down, like this one is just a single bit, right? Just a single bit. And
okay, so now we're on this register and put video control register 1.
Right.
And have a field. 1 bit.
Yep.
Not used.
Yep.
Okay.
So
field.
correct. Yeah.
Can you share your screen?
So the SystemRDL, it's kind of boring, but right on. So now let's look at, so to generate this. Yeah.
The whole register.
Okay. 1 bit for the reserved, 2 bits for bit depth. Sorry.
And that's using one of your enums there.
Correct. Yeah.
Okay.
It's using the bit depth encoding, which I set right here.
Oh,
You can.
okay.
So you can have a description and a name for every field within a register.
And for the enumerations as well. Yes. Everything can have a name and a description.
It's made up of numerous fields here.
Yeah. It's
Each sucking up with it.
right. It's very structured, and there's a very comprehensive document that shows how to do all this. And it's been around since 2009, so there's a lot of support out there if you run into situations where you're like, I don't know how to handle this. Yeah. So you got more reserved bits, you got scan method, 2 bits. Yeah. So that's a full register there. You can see that this is the input control register 1 at address 04. Okay, cool. So that command line, which I can obviously make much easier if need be, parses through this and generates all the outputs. So what are all the outputs? Well, we get a C header. It's empty. Actually, right now, this is dumping the C header output into the Decider software. So I relocated it at the moment. That way, all my software is up to date. I'm actively using this as we speak. So for all you Microsoft fans out there, it will generate. So it will generate a Microsoft doc for you. Ignore that because I accidentally left the PCIe part.
Plugin that you had to install or create.
If I put it in the build batch thing, so it's in there. You just have to know where it is. But my little batch script calls it up. So you get all your Microsoft docs automatically generated.
Can you slow down there?
Yeah, sorry, I'm sorry.
Thank you. Are you on speed today?
I've had two coffees. Yeah.
I've been ready to talk about this for
Yeah, so let's go back. We'll check out that register we looked at earlier. The, where are we at? Output, input video control register. All right. Input video control register. Okay. So module ID register. No. Where are we at? There we go. Input. We jumped to 3. I don't know how Microsoft works. Okay, this is over here. Register for video control. Cool. So this is pretty close to, I mean, it's not exactly how we do our Microsoft docs, but there's also no standard for how the Microsoft docs are
That's not true.
written or enforced. And they are also not enforced because I just had to deal with the problem yesterday where the module ID and the Microsoft doc was wrong for about an hour before I realized what was going on. Yeah, so this generates this out. Cool. Everybody loves Microsoft.
Where is, okay, so some of those we're using enums to find them.
Right.
Where are they? Where are those listed here?
I actually don't know where they get listed in the Microsoft doc. Oh, here you go. No, this is just the table. I really don't know. I kind of just threw the Microsoft thing in there because I was like, people are going to want Microsoft docs. But I would posit that it's maybe you'll never want to use a Microsoft doc ever again after I show you the other outputs.
Well, I don't care what docs we use, but if we're going to generate a Microsoft doc, but it doesn't have those enums in it, then it's not useful.
Right, correct. So it also generates HTML, which is super slick. So here you've got, let's go to our input control register. So here you've got your input video control register, your description, your contents. Now, let's say you're working on something, you're like, oh man, I would really love to see what the register is going to look like if the bit depth is set to 10. Oh, hey, there you go. You want to switch to radix? You can look at it hex, decimal, back to enumeration. You get the encoded register value down here. You can reset it to a 0. It'll reset this guy. You basically have a fully interactive pre-inspection tool for your register definitions. Also, maybe I'm looking for DVI-related stuff. Go check that guy out. Quick search functionality to find your registers quickly. This is all being hosted on Team Cities. Thank you, Lajay, for putting that up there for me. Yeah, pretty cool little tool. And also, like I said, instantly updated the second you hit compile. So if I change a register and I want to use it right now, I just hit compile and I come over here and it's loaded up. So that's the HTML version. What else do we have? Hide that. JSON will come in. I'll come to play later. You have Markdown in case you like your documentation get trackable, which is nice. So you have your little Markdown file that can go straight into your Git repo, also immediately updated. You get your Verilog modules. So these, okay, so I will admit, thus far, I have not had to integrate any of these. I didn't, the High 5 Plus was maybe the one place I was going to test and see about putting this in, but essentially this can replace your entire SPI RAM, not your dual port SPI, but your SPI RAM module that you're using in like the older style deciders, where it was all pure hardware. And because it can work with the AXI4 Lite host bus, you can also use it in other, it'll generate the AXI Lite for host bus stuff. Now, once again, I've only generated these, I've not used them, so I would be full of shit if I told you like this just works. I've done not the work to drop it in yet. If I get time, I'm going to try it, but it's been one of those things like, yeah, if it ends up in your critical path, do it. Now, the stuff that has worked exceptionally well has been the C header stuff. It's allowed me to refactor stuff. So like before we had a lot of these like see this. We had a lot of these things where it's like, oh, if you have this thing and it just equals to 1, this has allowed me to remove a lot of these magic numbers by generating, it generates a pound define for every single register value and a bit mask, etc. So now I can use this guy. And that's a little helper function. I was able to make it so that you can essentially quickly extract. It's not in this code, but I made a little extraction pound define macro that allows you to extract the bit fields that you're wanting, so that you can basically just have a single call that just gets whatever bit field you want using the generated C header files. I'll go ahead and show you those real quick. Okay. PeakRDL software. So I called it the HAL, which is incorrect. It's technically a RAL, register abstraction layer. And also, who wants to invoke Space Odyssey in this era? So yeah, it generates all these, which are just, it gets the command control status register high 512G, the register name, and then the sub bit field / the corresponding bit field you would need to know the generated. So you can technically use this to kind of, like our dual port RAM that we use in the software decider, we're essentially emulating the traditional control status register thing, but we don't have a lot of the functionality where like there's the default reset behavior, right? With this, you can do that because you've got your reset values right there as a pound define. So you could just iterate through and say, set all registers to your reset value. Similarly, you've got your enums over here, which you can use for the different RAL accessors. So this has been super helpful just in the past 24 hours. It allowed me to implement a feature add pretty quickly. The only missing part is that obviously these, nobody on the miniconfig side currently knows about these. So if you did something like, hey, I need to change the auto behavior of the entire device. Now, because right now, the way that system's set up, it defaults everything to 0 when it comes out of the factory. In order to change that default behavior of a device from, say, like, oh, we don't want auto mode to be the default behavior. We actually want HDMI mode to be the default behavior. It's relatively simple to go to SystemRDL and just change this to a 0 and this to a 1. If miniconfig was looking at these C files, it could automatically update like that, and that would require no human interaction. Now, cool, right? So this is like the really in the weeds part of all this, and that's PeakRDL. Now you might be saying, but wait, there's more. Introducing Peekaboo. It's the PeakRDL to basic UI. How does it work? Well, let's find out.
Did you make it?
Well, Claude made it with a little bit of guidance. I would never take the time it would require. I started doing it, and then basically it was like, oh, this is going to take too much time. And then Doug told me to investigate using Claude. So the other day I fired it up and had it finish all the parts that I hadn't finished. So you can have it load in the RDL file. Now you've got the entire register map here. You can come in here, find yourself an AUSP module interconnect. This happens to be a high 512G. I don't have any functionality for detecting what kind it is yet, but that's okay. I connect. I'm now connected to the high 512G at my desk. You have several fields here. You've got the register, which shows the general register value, the register address, the bit fields. You have your desired value, which you would think of this as like what I want the registers to be. This is what the current actual values of the registers are. And here's an indicator to tell you whether the actual matches what you want it to be. To sync them up, you hit sync. Cool. Let's say I wanted to. These are all read-only, so I can't change them. Let's say I want to change scan method to progressive. I change that, hit apply. That just sent a message down and caused the device to change that field. Sync back up. If I don't want to look at the decimal formats, I can change it to hex for each field. So if I want the enums over in here and the actual, I can see the enums. Cool. If I'm like, oh, I only want to see the HDMI high-low, and click that guy and maybe this reserved bit. And if I go to my watch tab, it has isolated those so I can see just those fields, the only ones I care about. Same thing. You may have noticed this green button going refresh. This is a heartbeat, which you can set with the refresh rate that will change how often it pulls that register to update the contents. And if you really want to see it, this is just the raw status view. It's what the actual is showing, but it's kind of just more isolated. And if you're interested in what's going on under the hood, I have the communication log over here. I'm also planning on adding at some point logging that will show when certain registers changed in time. So if, say, you are observing behavior where like, oh, hey, when I change this guy to reserved and apply, I see a bunch of weird behavior on the far side, and I don't know what's changing where, and maybe it's help you investigate some kind of register values that are changing that are just maybe too fast to see. You'd maybe come over here and change this to 500 milliseconds. And now you got a higher refresh rate, and the plan is to add logging so that it'll create a log file that say like this, it'll create logs that say like you asserted desired at this point, these values changed at these time points. That's long-term planning.
We have a separate sync Why is sync separated from refresh?
Because you may not want the value, because so sync actually synchronizes your desired from the actual. So sync copies all the actual into your desired. That allows you to manually update your desired to what the state of the system is. It's a little bit.
What the hell does refresh do?
It's updating the actual. So you're watching the values of the registers change in real time. Sync will just change this guy. So see here. You also got all your fun Excel style behavior here.
So you can apply basically means take the desired and push it to action.
Correct. Yeah.
So,
And if you ever get confused, you can just hover here and it'll tell you what it does. Correct. Yeah. So if you see pending, it says the value that is the actual value is not what you think it or what you would like it to be currently. But if you want to just have your system update to what the actual state of the system is, boom, you're synced up.
This is on the serial code support, or is this over USB?
This is using the mini converter serial protocol, but I also wrote it, i.e. Claude wrote it, to have an extensible backend so you can swap out the MCSP for whatever your protocol of choice is.
So is this using the USB or the constant one?
USB.
Thank you.
Okay, so this ostensibly could replace miniconfig should we decide to do so.
You didn't hear me say that. Also, if you leave it alone for 30 seconds, you get a little ghost.
Oh, sure.
Yeah, so that's some of the, I tried not to like include that too much into this presentation, but it would be negligible. Yeah, well, you know, I'm trying to let people kind of. So SystemRDL is very easy to modify, and in ways that won't break PeakRDL. So if you added a field here that said UI parent, UI type, and whatever, you could essentially have this document get parsed and generate your miniconfig on the fly. And this would be like you, the hardware engineer, change the register, and 1 minute later, you've got an up-to-date miniconfig.
So
I'm not going to pretend that's easy though. Like I don't want to sell this as like, hey, with this, what I'm selling right now is peekaboo.
So yeah, you said this is written to do MCSP, but does MCSP emulate CNC app or?
CNC app is essentially the bridge. CNC app is the device, the software base that catches CNC app packets and converts them into action.
Is this equivalent? Do I have to do anything special to take an existing something that has a FX2?
No.
Plug it in.
This is running on a raw high 512G that runs like, and I'm just interfacing over the MCSP. Don't try and do any updates with it because it's not going to work the way you think it's. But I don't think there's not even the functionality to do that in here. So, but all the basic register interface stuff is all here. It essentially just uses the data immediate stuff, and we do kind of a weird thing where when we set our data, we use multi-packet transfer, but when we get our data, we use the immediate, which is fine. It actually makes the refresh work really quickly, which is cool. But like I said, this application is designed as a model view controller architecture. I know everybody loves that, and with an extensible backend. So if you were like, hey, I want to use this on this other device, all you got to do is swap out the backend. I don't have hooks here for doing that, but it would be negligible to basically swap out your protocol, your serial protocol for whatever method of communication you're using to get access to the registers. Very, very, very easy to do, especially for Claude.
It's a great tool, just you're working on it.
Oh yeah.
You have many support, right? Because a lot of times you don't have it when you're working on the converter.
It was incredibly helpful yesterday when I was trying to put this feature in. Like it turned something that probably would have taken me 3 days into like a 2-hour thing because I was able to watch the registers and send them over here and be like, oh yeah, I know I want to see what happens with these guys when this thing changes. And obviously some of the older, having done the High 5 Plus and the High 5 12G, I noticed that in the High 5 12G, we exposed a lot more of the internal state to registers, which is great because it really gives you a deep look at what's going on in the system, which I was like, oh, this is great, man. Like, I don't have to run any debug points on my decider code.
Well, the earlier mini converter deciders were older than internal.
Right. And this is good for those too. But yeah. So, and at this point, all you have to do is just have the JSON generated from the SystemRDL. I could update this so it could just ingest raw SystemRDL, but I want JSON. And the thing generates so many different outputs. So it's like, JSON was a little easier for Python to parse too. There's a lot of packages out there for like ingesting JSON files and turning into UIs. It's a very common thing. Yes. Okay. So I think we're almost done. Just wanted to...
Does anyone use the C code besides you?
No. No, not at all. The cool thing is if you drop it into your project, it can operate right beside everything else. So it's not like if you drop it into a project, it doesn't break anything. It's just a feature add. And please, if anybody has questions about this or wants to try Peekaboo, let me know. Like I said, there's more. There's Peekaboo. There's a little guy. Also, SystemRDL is not limited to registers. Now, here we're going into some weird stuff that I haven't done anything with, but you can also define wires, interrupts, write enable strobes, counters, event flags, all kinds of Verilog stuff. I don't know if PeakRDL has any tools in it to generate the interfaces from this, and I don't know if anyone would even use it, but it's cool to know that like when they developed SystemRDL, it was essentially to create these common hardware-software interfaces so that there was a common language between the two. Yes. Would you like to know more? I would highly recommend, I'll share this PowerPoint presentation. You watch Alex Mitka's FOSSI presentation where he talks about this. I sold pretty much 90% I sold probably 99% of all of this from him. The only thing I contributed was Peekaboo. SystemRDL, and I'm sticking with that name, even though I would like to point out, I named it before I realized it was the wrong type of peak. Because I'm a good speller. But I'm sticking with it because I think it's cute.
Double entendre.
Yeah, that's correct. Alex Mitka's FOSSI presentation, really good. The SystemRDL definition doc is publicly accessible, but also, like I said, there's a ton of, if you Google for it, you're going to find support. The PeakRDL docs are very helpful. I mean, I stood this whole thing, the initial PeakRDL build I stood up in a day, and I would say probably a half a day from PeakRDL docs. And if you want to get Peekaboo, this link will take you to the directory, on the FTP directory I support on the shared drive where I keep all the system tools I generate, and I will update it from time to time. And if you have a feature request for Peekaboo, like you're using it, like, hey, I want to do this, you could either fork it and clod it yourself or write the code yourself if you are feeling ambitious, or ask me and I'll crush some, I'll token max on it a little bit. And in summary, PeakRDL, SystemRDL, I'm not saying, hey, everybody go use this. I'm just saying, if you wanted to, I'm here to help you. It's not about replacing how we design. It's about removing repetitive work, eliminating human error, which is a big one, and making systems easier to maintain and expand. And improve communication is like my big one between hardware and software, because that's a recurring issue from time immemorial. Yes, and with that, this is the conclusion of my presentation. I will take any questions, comments, concerns at this time.